Good evening, everyone. Welcome to PyRVA's September lecture series. We have with us Simon Willison. He is one of the co-creators of Django. He is the creator of Dataset, which is one of the programs that he will be covering tonight. And he has recently just finished a JSK Journalism Fellowship at Stanford for developing tools for journalism. Before we get to Simon, we have a few announcements for PyRVA. First off, if you are a member of PyRVA and you are in our Discord server where we start all of our meetings, if you are interested in winning this month's PyCharm giveaway, leave a comment in the text channel and I will tally up everyone who is interested in PyCharm license and do a random drawing at the end of the night. Another big milestone for PyRVA is next month in October. On the 14th, we are celebrating our 5-year anniversary of existence. We are hoping to get a bunch of people to kind of do some lightning talks and share how Python has helped them out in their lives or the projects that they're working on. So if you're interested in talking during that, get in touch with one of the organizers, either me, myself, or me, Mike, or Chris, and we can get you in the rotation. At PyRVA, we do 2 series of meetings. This is our lecture series, which is the first Wednesday or second Wednesday of every month. And then we also have coding nights where we kind of, on Thursdays, I think it's the 4th Thursday, where we put your skills to the challenge and give you some exercises to work through as a group or as an individual. And yeah, so without ado, we will bring Simon on. Hello, Simon.
Hello, can you hear me okay?
I can hear you.
Fantastic.
Thank you.
Hi, everyone. It's great to be virtually here in Virginia. I don't know if you can tell, but the sky is a sort of weird orange color behind me. I'm in San Francisco, and we've had, California is essentially on fire at the moment, but we're okay here for the moment. So if I suddenly rush out of the room because something catches fire, I apologize in advance. So today I'm going to be talking about rapid data analysis with SQLite and Dataset. And really, this is an excuse for me to tie together a whole bunch of different projects I've been working on over the past couple of years. And the key theme of these projects really is, I've been calling it small data. Like, everyone talks about big data and how you want to have like a giant data warehouse running Hadoop clusters with terabytes of stuff. But these days, a terabyte of data will fit on your phone. And I think there's something really interesting about thinking about these smaller data, these small data problems where a database is super useful. You don't need to deal with terabytes of data, but you want to try and as quickly and agilely as possible get to the insights in these smaller data sets. And data is all around us. Data is eating the world. There's so much data available about just ourselves and data within our companies. So building tools that let you really productively work with that is something that I'm becoming really passionate about. So I set up a Google document for this talk. The link to this is in the Discord channel. I'm using this for Q&A. So as I go along, if there are any questions you want, feel free to add them in here. I'll be fleshing out the answers after the talk and turning this into a handout. But for the moment, please feel free to use this as shared notes as well. So let's talk about Dataset. So Dataset is an open source multi-tool for exploring and publishing data. That doesn't tell you too much, so I'll dive straight into a demo and show you the kind of stuff you can do with it. So this is a Dataset instance. Dataset, fundamentally, it's a web application that sits on top of a relational database and lets people interact with that database. So this is COVID-19 data published by the New York Times. The New York Times publish this every day in a GitHub repository. I've got a script which takes their data and sticks it in Dataset so that you can start working with it. And out of the box, this isn't very exciting, but where it gets interesting is where we start to filter it. So I'm going to say, give me everything in the state of California. And this is that we can click in and say, hey, it looks like we can group these columns by county. So is there a county that you're interested in? I can say, yeah, show me San Francisco County. And so now I'm being COVID-19 reporting on cases and deaths per day in the county of San Francisco up until what this is yesterday, I think. And this right here is exportable as JSON. So if I want to run automation against that, I can write scripts. I can pull the data out as CSV. So I've just filtered down to San Francisco, California. I can get a CSV out of it. And I can also do things like visualizations. Dataset has a plugin system. I wrote a plugin that does simple charts. So I can say, I want to see a line chart that plots the date against the number of cases. And now we've got and actually I want this to be treated as a date time. And so this is a chart of cases that have been identified in San Francisco County over time. And that's bookmarkable, so I can share that link with other people to show them what's going on. So that's a sort of very simple example of a data set that's just some columns with some numbers in. Here's a more interesting one. This is a database of global power plants. These are power plants published by the World Resources Institute. And again, they put this up as a CSV file on GitHub. And so I can load this into a table and see, Afghanistan has this power plant with this capacity and it's hydrogen and so forth. But this data set's fun because two of the columns in there are latitude and longitude. Oh, I can't actually see those now. And I have a plugin for dataset which looks for latitude and longitude columns and turns them into a map. So now I can generate a map of all 33,000 power plants in the world. And I can do things like zoom in and say, hang on a second, what's this down in Antarctica? But it turns out McMurdo Station in Antarctica has its own 6.6 megawatt generator. And there's another one just down here on Ross Island. So starting with that table of data and loading it into something that can then apply these automated visualizations on top can do some really interesting things. The fundamental sort of secret sauce behind all of this is the SQLite database. So you've definitely used SQLite because it's the world's most widely deployed database engine. There are SQLite databases in my phone. My laptop is full of them. I'm pretty sure they're running on my Apple Watch as well. And it's got some really interesting characteristics. Firstly, a SQLite database file is a single file on disk. It's a .db file, and it's a binary file that you can email around and back up and so on, which means that it's really easy to create these things and then store them somewhere. It's optimized to run on mobile phones, which means it's really fast. So once you've got it up on a web server, you can do all kinds of really quick queries against it. And really, the only disadvantage of SQLite is it's not great for receiving concurrent writes, like you might have on a high-traffic web application. But for the kind of purposes I have, which are mostly publishing these static databases, all of it, that's not a problem at all. And actually, this is a really nice way of bundling up some data and putting it online. In fact, all of these demos are I'm basically abusing the modern idea of serverless hosting, where you have services like Google Cloud Run or Heroku or Vercel, which say, hey, you can deploy your stateless web application to us. If you want to have a database, that costs extra. You have to pay for a Postgres or a MySQL somewhere. But because I've got read-only data, I literally stick the data in this binary file in a Docker container and deploy the entire container with the application code and the data bundled together, which means that it can scale by firing up new instances of containers, and nobody can cause any damage to it. And that's super useful because one of the features of Dataset is that I can do things like, so, show me all of the gas power plants in Russia, and then I can click View and Edit SQL, and I can actually edit the SQL query that's being used for this page. I'll click Format here. So I can say, I just want country name, capacity, latitude, and longitude, and then get rid of all of the other columns. And it's safe for me and I can run that query from my browser. And because the database has been opened in a read-only mode, I can't cause any damage. So SQL injection, which is normally a major security hole, becomes a documented feature of how this software works. And this also means that because this has a JSON API, I've now got a JSON API that accepts a SQL query in the URL, executes that, and returns the results. So I have done this. I can write SQL in my JavaScript, send it to a backend, get the results back, and do useful things with them. So to illustrate quite how widespread SQLite is, this is a Mac command that you can run, which finds all of the SQLite databases on your machine and orders them by size. So if I run this, in fact, I'll run this without the head command. Let's type through wc-l. I've got 1,124 SQLite databases on here. And let's do head dash, I'll do head dash n 10. Here are the 10 biggest ones. So looking through this, the biggest SQLite database on my computer is photos.sqlite in the Apple Photos library, which is, I think that's 857 megabytes of data. And so I've got dataset installed locally. I could type dataset and give it that path. And this will start up a little local web server running dataset against that database. I can stop being around it, but this is all internal implementation details of how the Apple Photos app works. But one of these things stands out to me straight away. There's something called zCloud Master Media Metadata. If I click on that, it's got 44,000 rows in it. I happen to know that I've taken 44,000 photographs. So it looks like this is one row for each of my photos. But the data is in this Z data column, which is looking a little bit garbled. But I noticed that this is BP list 00, the first characters in that column. So Apple have a format called a binary plist. And I wrote a dataset plugin called dataset-bplist that knows how to introspect that data. So I'm going to install that plugin. Dataset install, not dataset insert. Dataset install dataset bplist. And it's installed that from PyPI. I'll run this again and hit refresh. And now that column has been decoded for me. And I can see that this is some pretty fascinating data. I've got the time I took a photo, what like make and model of device. I've got EXIF data. I've got the exposure. And then most interestingly of all, I've got GPS data. So there is a SQLite database on my computer that knows exactly when and where each of those photographs was taken. And I'll be coming back to that in a little while, because there's some really fun stuff we can start doing with that. Yeah, so as you can see, there is data in this format all over the place. And Dataset just gives you this sort of instant interface for starting to interact with it. You can run it locally on a laptop, which lets you dig into your own data, or you can run it on a web server, which means that you can publish data and let other people see it. So the obvious question, though, is how do you make these things? If Dataset works against SQLite databases, you need to be able to make SQLite databases. And so I've spent quite a bit of time over the past couple of years building tooling to help on that side of things. So Dataset will read SQLite and let you explore it, but I need tools to help me create SQLite databases. The main tool I've been working on is a library called SQLite Utils. It's not the snappiest name, but this is a combination of two things. It's a Python API for quickly creating SQLite databases, and it's also a command line tool that lets you manipulate those on the command line itself. So if we go back to this photos example, I can type SQLite-utils tables and it'll show me all of the tables in the database. If I add -- counts on the end, it'll give me a count of rows. This outputs as JSON by default, but if I add -t, it'll show me in a table. So this is just one of the many things this tool can do to help you interact with these databases. The really fun stuff is when you use this to create a database. And so I'm going to do a live demo here where it turns out the USGS publish a GeoJSON file with all of the earthquakes that are going on in the world right now. As far as I can tell, they update this every few minutes. And this is so this is a live view of earthquakes around the world. And it comes back as GeoJSON, but I'm going to manipulate this a little bit and turn it into a SQLite database. So I have a Jupyter notebook. I wrote these tools initially the goal was to have them work in Jupyter. And so I'm going to paste in that URL. I'm going to use the HTTPX library, which is a modern equivalent of requests, to load in that data. And here we go. This is that GeoJSON data pulled back from that API. Actually, let's see how much there is in there. So len GeoJSON features. There are 2,292 earthquakes in this at the moment. If I pull out just one of those, you can see that each one is a thing with a type of feature, a list of properties, and then a geometry, which gives you a latitude and longitude. To use this, I need to convert it into flat dictionaries to use those with this library. So I'm going to write a quick function which does that. So this function reads out the properties, it adds the latitude and longitude pulled out of the geometry, and then it returns that. And actually, I just noticed there's an ID column here as well. So I'm going to do DID equals F ID as well. So now I've got an ID in this too. So I've got a function which can turn these GeoJSON files into dictionaries. I'm now going to import SQLite utils. And then I can, actually, I'll split this up to make it a little bit more obvious. I can say db equals SQLite utils.database and give it a path to a database file. And then if I do db square brackets quakes dot insert all and call that function against each of those features, the insert all function looks at the shape of the data that you're passing it and creates the database schema for you. So I can run this and, oh, it didn't like that. Why not? db quakes, because I forgot the insert underscore all. So I can run this and it creates me a table. If I ask it for the schema of that table, dot schema, and I'll put print around that, I can see that it has created me a quakes table with float and text and integer columns for the various data that came in there. But I added this to a file called /temp/earthquakes spelt wrong.db. I can now run dataset against that. So I say dataset /temp/earthquakes, open this up, and this right here is that database of earthquakes, which I've just created interactively. And because it's got the latitude and longitude column, I'm seeing it on the map. So this is a map of all of the earthquakes. Wow, that's quite exciting. Let's see if there's any near me. Oh, look, there's one right there. That was 4 kilometers southwest of Muir Beach. Trying to see if there's a... It looks, oh, it's a 1.3, so it's not exactly one that you'd feel. But the other thing that I can do here is I can start faceting. So this suggests columns that are interesting based on a very simple rule of thumb. It says if a column has less than 20 unique values in it, then suggest that as something you might want to facet by. So I can facet by tsunami, and oh wow. So I'm going to look at just the reviewed earthquakes. And of those, 5 of those are tsunamis. This is a map of all of the earthquakes that have been classified as tsunamis in the past. I think this is the past week's worth of data. But hopefully what this illustrates is that given a source of data in basically any shape you like, right? In this case, it was GeoJSON, but you could imagine this working against regular JSON or XML or data that you scrape off a web page. Using the SQLite utils library just makes it it's a couple of lines of code to turn that into a SQLite database, which you can then start visualizing and exploring and run queries against, and even potentially publish that to the internet. You know what? I'm going to do that. I'm going to publish this to the internet quickly. So one of the features of Dataset, there's a command called dataset publish. And what dataset publish lets you do is it lets you publish databases to the internet using a variety of different publishing platforms. Actually, I'm going to rename that database to /temp/earthquakes.db. And at the moment, Dataset Publish is giving me the options of Google Cloud Run or Heroku. I'm going to install another plugin called Dataset Publish Vercel. I like Vercel for these demos because their deploys are really, really quick. Now, if I do Dataset Publish --help, I've got Cloud Run, Heroku, or Vercel. So I'm going to say dataset publish Vercel /earthquakes. And it's going to say I need to give it a project name. So I'm going to say project equals earthquakes, project earthquakes demo. And this is going to start churning away. It's going to take that database file, upload it to Vercel, run a quick build. Vercel actually compiles these things into AWS Lambda functions, which is one of the reasons it's so quick. Gives me a little inspect URL where I can see what's going on. It's installing requirements, and in just a few seconds' time, this should turn into a live website that anyone can go and visit. Here we go. And so I click visit, and this is that database that I just created in a Jupyter Notebook, published on the internet for anyone to see. You'll note that this doesn't have the map on it. That's because I need to install the dataset cluster map plugin as part of that deployment. So if I run that command again, it'll create a brand new deployment, but it'll install an additional dataset plugin called dataset cluster map, which will then give me the, which will then show up on this page. So the focus on publishing, really, it's because configuring and deploying web applications is still such a pain. And I figured if I want to, here we go, earthquakes-demo.vercel.app. It gives me a nice URL. And this right here is a map of all of the earthquakes from the last week deployed to the internet in just a few seconds, which I think is a super useful thing to be able to do, especially if you're, if you're working in a newsroom, if you're a data journalist. I think I've just found a bug. Yeah, that's a good bug. Look at this. It's showing, it says 250,000 of 2,292. So I'll cut that off and I'll follow that one way to fix later. But yeah, so the idea here was to encourage newspapers to publish the data behind the stories that they're putting in the newspaper. So I've been building a whole suite of different tools for solving this problem, for how can I productively turn data into a SQLite database so I can run queries against it and publish it and do all of these different things. The first tool I wrote was called CSVs to SQLite, which unsurprisingly converts CSV files into a SQLite database. I recently built one called Shapefile to SQLite, which can take geographic shape files, the Esri standard, and load them into a Spatialite database, which is an extension for SQLite that adds various, it's kind of like the Postgres geospatial stuff, but for SQLite. And so I have a database running here, which is protected areas in California, so essentially state parks and such like, which is running on a Spatialite database loaded in from a shapefile. So if I search for Golden Gate, I can see Golden Gate Park in here. And because this has geospatial data, I have a dataset plugin called Dataset Leaflet GeoJSON that can turn that into a rendered map. And you can run geospatial queries against this to find parks that are closest to a point and things like that as well. Lots of people have data in relational databases in Postgres and MySQL. I've thought about getting Dataset to run directly against those, but I'm a bit nervous about committing to maintaining yet another database abstraction layer. So for the moment, I've got a tool called DB to SQLite, which you can feed a connection string to Postgres or MySQL, and it will suck down the entire database or specific tables that you request, load them to a SQLite database for you. So I've been using that for things like running Dataset against my blogs database, which is a Postgres database up on Heroku. So that's hopefully given a reasonably clear idea of what Dataset is and what I'm trying to do with all of this tooling. But the other thing I wanted to demonstrate today is some work I've been doing around the idea of personal analytics. As I mentioned, I'm interested, like data is everywhere, and I'm particularly interested in what kind of insights can we get from the data that we can get our hands on. And the inspiration for a lot of this work was an essay that I read 1.5 years ago by Stephen Wolfram. And this essay is a journey. It's entitled Seeking the Productive Life, Some Details of My Personal Infrastructure, which is a wonderful title. And the main feature of this is the scroll bar. If you start reading this and you realize that this thing just goes on and on and on. This is Stephen Wolfram has been working for a work-from-home CEO running a 1,000-person company for the last 28 years. And I guess he basically, he's been doing the COVID work-from-home thing just 28 years longer than the rest of us. And he has spent those 28 years optimizing every single inch of his life. So he has like standing desks, and then his heart rate monitor showed him that his heart rate's healthy when he's outside. So he rigged up a way of using his laptop and going on walks. And he scanned every document he's ever created since he was 11 years old. He built a green screen setup in his basement so he could give talks from home. And there's just so much stuff in here. It's completely overwhelming and kind of crazy. But there was one thing in here that really sort of stuck in my head. He talks about how he has a meta searcher. So he has a personal search engine which he can run searches on, and it searches every email he's ever sent, every file on his machine, every paper document in his archives, all of these different sources of information, all to be searched in one place. And so I read this and I thought, well, I kind of want that. I'd love an idea of having my own personal search engine for just my own personal data. And because his name is Stephen Wolfram, and I'm building something that's inspired by Stephen Wolfram, but isn't nearly as sort of good, I decided to call it Dog Sheep. So it's Wolfram inspired Dog Sheep. And so I've spent the pun, and to be honest, I enjoyed the pun of calling it dog sheep so much that I've spent the last year building the tools to support the pun. This is essentially pun-driven development. So I will give you a demo of my personal dog sheep. So the idea with dog sheep is it's a bunch of tools for pulling in your personal data from anywhere you can get it from, out of Twitter or Facebook or LinkedIn or Apple Watch data, all of this different stuff, and getting it into one place. And then dog sheep, it's my personal dog sheep, is an instance of data set that I'm running against my private files. So this is only available to me, and it's got data from a bunch of different sources. It's got my Twitter data, HealthKit for my watch, all sorts of GitHub data. It's got check-ins I've done using Foursquare Swarm. I've got a copy of my blog in there, a whole bunch of different things. And this means I can start doing some really fun stuff. So as an example, I've loaded in every commit I've made to any of my projects on GitHub. And so I can start looking at those. I get faceting, so I can say, oh, just show me the 350 commits to SQLite utils. But because they're all in one database table, I can run searches across all of them. So if I type PyTest, I'm now seeing every commit across all, like, I've lost track of how many repositories I've got that mentions PyTest in the commit message. Also, with all of this, I can do things like construct a SQL query, which truncates the date down to just the day portion, and then groups by that. And then with the visualization plugin, I can turn that into a chart. So this is a chart of my commits per day over time, based on just a SQL query that I wrote and then bookmarked and linked to from my homepage. I check in with Swarm whenever to places that I go. And so I've got all of my check-ins, which is kind of fun. Poplar State Beach I was at yesterday. But more importantly, anytime I check in with my dog, Cleo, I use the wolf emoji as part of the check-in message, which means that I can run a SQL query where I say, select everything where shout like wolf emoji, because it turns out you can put emojis in SQL queries these days, join that against venues, pull out the latitude and longitude, which means I've now got a map of all of the places that my dog has been. So this is basically Cleo's personal map of the San Francisco Bay Area and the places that she likes to visit, which is clearly an incredibly useful thing to have. I mentioned Twitter. So I suck in all of my tweets, that's fine. All of the tweets that I favorited, and I favorited over 25,000 tweets now, so I can search and join those in one place. Everyone who follows me on Twitter, which means I can do things like search my followers for people who are following me who mention something in their bio. So if I want to talk to, like, I don't know, a journalist or a VC or something, I can do that. I've got saved searches that I run on Twitter. So I search for various projects, or like once an hour, I run a search for data set and index the tweets from that. And that means I can do some super useful things as well. So Cleo, the dog, again, has her own Twitter account. And every time she goes to the vet, she tweets a selfie and she tweets how much she weighs. So she says, I weigh 42.3 pounds. I grew more dog. What I can do then is I can construct a SQL query which looks for those tweets that mention her weight, runs a regular expression to extract the weight as a value, sticks that in a column, and then I can plot that over time. So I've now got a self-reported weight, a Cleo's weight graph over time based on running a regular expression against her selfies that she's tweeted, which it's hard to think of a more useful way of applying this software. Except I did 23andMe a few years ago, and I recently realized that 23andMe have an export button. You can export your genome back out of 23andMe. So I have a copy of my genome in Dataset. It's not the entire genome. It's the 600,000 rows that are most useful for finding out creepy things about you. And I took this to a science hack day last year, grabbed myself a geneticist, and managed to figure out how to run SQL queries against my genome. So this is a SQL query that tells me what color my eyes are. Apparently my eyes are blue 99% of the time. Obviously, I mean, that's kind of amazes me that we can get access to this stuff and do fun things with it. Another huge source of data for me is Apple HealthKit. So I wear an Apple Watch. The Apple Watch, one of the things I love about Apple is that their really non-creepy with this stuff. They don't upload it to the cloud for you. They keep it on your watch and on your phone. And they give you an export button on your phone itself where you can get this data back out as a giant zip file full of XML. So I wrote some code that turns that zip file full of XML into SQLite tables. And now I've got a very deep insight into everything that the Apple Watch has recorded about me. So it knows my heart rate variability, my resting heart rate. It analyzes my sleep. It tracks my mindfulness sessions, although I've only had one mindfulness session because it turns out I'm not a very mindful person. Flights of stairs I've climbed. And then the most fun one is every time you track a workout on the Apple Watch, it records that as a database entry, and it also reports your location every few seconds for the duration of that workout. So I ran the Beta Breakers race in San Francisco 2.5 years ago. And if I click load all on this, it'll show me the exact route that I took during that race. At a very, very, like this is every few seconds, it's recording my latitude and longitude, my altitude, the speed that I'm going at, the whole works, which I've actually, since discovering this, I've started tracking walking workouts anywhere I go, anywhere interesting at all, especially if I've got my camera with me, because then I can try and match up the location to the photos later on. Speaking of photos, so I showed you that Apple database earlier on, the database file on my laptop of all of my my photo data. And it turns out Apple do a bunch of really interesting things with your photos. Anytime you take a photo and it gets loaded into Apple Photos on your phone, Apple then run a machine learning model against it on your phone to figure out what's in the picture. So Google Photos will do this in the cloud. Apple actually run these things on device overnight when you're plugged into a charger. And I figured out how to get all of those labels back out again, which means that I can run a SQL query that shows every photograph I've taken of a pelican according to Apple's machine learning model and its ability to identify pelicans. And it's pretty good at this kind of stuff. So query takes a moment to run, but I'm running this query, which will show me every photograph I've taken of a pelican. Here we go. There we go. Here are all of my pelican photos. And on top of all of that, it turns out Apple calculate a bunch of scores for your photographs, which come up as columns. So there's a column called Z overall aesthetic score. There's Z harmonious color score, Z interesting subject score. There's one here called Z pleasant camera tilt score. And these are all invisible. They don't tell you about these in the application itself. But once you dig into the database, you find out that they've been judging all of your photos on this amazingly wide-ranging variety of characteristics. So this query here isn't just showing me photos that are of pelicans. It's ordering by aesthetic score. So it's ordering by which photographs Apple think are my best photographs of pelicans. And again, this is just so much fun. I can resort this by camera tilt score and see pleasantly tilted camera photographs that I've taken and so on as well. So I've been having an awful lot of fun combining all of this stuff together, loading in data from all of these different sources. But the thing I built last week was sort of the culmination of all of this work, the thing that I wanted to get to. And that's a thing that I'm calling Dogsheep Beta. And the reason I'm calling it Dogsheep Beta is that Stephen Wolfram has a search engine called Wolfram Alpha. And again, my thing is not as good as his thing. So Dogsheep Beta felt like the appropriate name for what I've been building. But Dogsheep Beta it's a search engine. And what this lets me do is it lets me load in and combine all sorts of different data. So in this, I've got my tweets, my photos, my GitHub commits, blog entries on my blog, hack and use comments that I've posted, GitHub releases, all of this different stuff. And now I can run a search for it. So I can search for, I wonder if I search for PyRVA, let's see if I get anything back. And it's, so here there we go, 8 tweets about PyRVA, 1 of which I created and 7 of which I saved. So I favorited those tweets. A really fun demo search here is Cleopore's costume, because Cleo has an excellent line in costumes. She's won costume competitions before. So this shows me 12 tweets and 1 GitHub issue comment where Cleo's talking about the costumes that she's worn. And that's Cleo dressed as a pirate, which is, I think, that she pulls off the pirate look really, really well. So all of this stuff is open source. Every single thing I've shown you is available on GitHub somewhere. If you go to dogsheep.github.io, this is a index page linking to, I need to update this actually, linking to a bunch of the tools that I've written. So Twitter to SQLite and HealthKit to SQLite and Pocket to SQLite and so forth. The newest repo is, and these are all under the github.com/dogsheep organization. So Dogsheep Beta is the new search index, which I've really just got working a few days ago, and I need to fully write up a tutorial on how to get that up and running. There is a lot of assembly required. You need to get API keys for things. I'm running a little Lightsail VPS instance with a ton of cron jobs on. So every few minutes, it wakes up and it ingests data from Twitter or from iNaturalist or from one of the other sources of data that I have. But cron works really well, it turns out. It's sat there quietly filling up. I think I've got 8.5 gigabytes of data just from my own personal analytics at the moment. And then I'm also running I'm running that private dataset instance, which is actually just regular dataset protected by a plugin I wrote called Dataset Auth GitHub, which does it gives you a GitHub authentication bounce. As you can tell, plugins are a very important part of the dataset ecosystem. If you go to the dataset documentation and look at the ecosystem page, this is a list of not just these tools for creating databases, but also the various different plugins that I've been putting together. Almost all the plugins are by me at the moment. I'd like that to change. If you want to start mucking around with the stuff, I'd be delighted to see more plugins that were written by people other than myself. But yeah, and so that's a sort of whistle-stop tour of the ecosystem that I've been building around this stuff. And I'm going to switch over to the Q&A document and hope that we've got some questions. Yes, we have. Fantastic. How many plugins are there for Dataset and how many of them are official? It's about 30. Basically, anything written by me that's doesn't have alpha in its version number, you can consider an official plugin. I think there are at least 2 that weren't written by me. And again, I'm crossing my fingers for more. How does safe read-only SQL injection stuff work? So there's a few layers to this. SQLite has a mode called immutable mode that you can open files in. When you do that, SQLite basically disallows all writes to the file, and it also speeds things up because it doesn't have to do locking and so forth. Some of my databases are accepting writes, the ones that there are cron jobs updating. So you can also open a file in just a straight read-only mode, which prevents writes but still allows reads. It's not just read-only. I've also got a timeout that I have on those queries. So if somebody deliberately sends you an expensive SQL query, Dataset will try and run it for up to a second, and then they'll cut off with an error. I have a Postgres database listening. I was thinking about using a central data repository from stuff. Is it better to proceed with SQLite for learning data crunch or go ahead with Postgres with output running ready to go? I don't know if I can answer that question. I love SQLite for this stuff because mainly, I love the fact that it turns your databases into basically disposable artifacts. Like you run a script, like the earthquakes one I just did, it creates a file that's like a couple of megabytes. You muck around with it for 30 seconds and then throw it away. And you can do that with Postgres, but it always feels to me like you're making a bit more of a commitment when you spin up a Postgres server and create databases and add tables to it. That said, I mean, all of these personal projects comes down to what you want to learn. If you want to learn to learn the sort of extensive things you can do with Postgres, then stick with Postgres. But obviously, I'm very heavily on the SQLite bandwagon now because it keeps on impressing me with it. Like I keep on trying weirder and weirder things with it, and it tends to just work. How often does Dogsheep pull data? I noticed the tweet tonight showed up when you search for PyRVA. I hit my Twitter timeline once every 10 minutes, I think. I mean, basically, with all of this, it's whatever the rate limits will let me get away with. So Twitter have quite generous rate limits for some of their endpoints and really strict rate limits for others. And I spent quite a lot of time experimenting with what cycle of cron tasks work best for what. But I'd estimate I need to clean up the cron tab and publish that just so people can see it. I think I'm probably running a couple of hundred processes an hour hitting all of these different endpoints. How are your tools auto setting guessing the data type for each field? So if it's JSON, one of the things I like about SQLite is it only has, I think, 3 data types. It does strings. Oh, no, it's 4. It does strings, integers, floating point numbers, and binary blobs, and that's it. And those happen to map almost exactly to what you get in JSON. So if the JSON object has a string or a floating point or an integer, I know which column type to use. And then from the Python, the Python version of the library, if you give it a binary string, like a Python byte string, it'll create a blob column. It's actually, another thing I like about SQLite is it doesn't bother with, you don't have to bother with giving it length, like varchar 255 or anything like that. It's just a string or an integer or a floating point. So it's great for very quickly splatting data of all sorts of shapes into a database table. Another thing that I do is the tooling I've built, if one of your columns or one of those fields is itself a nested list or dictionary, SQLite Utils turns that into JSON and writes it into a text column in SQLite. Because SQLite has built-in functions for dealing with JSON, kind of like Postgres and MySQL do these days. So that's great because it means that your data can be a completely bizarre shape, and you can stick it in SQLite with like 1 line of code and then start inspecting it and pulling out different fields and so on. Can you adjust the SQL timeout? Yes. You can run dataset with --config time_limit_ms:2000, and it'll up that limit. And did you look at any other backend like Redis, or does SQLite just immediately work? So the inspiration for this project was, it was literally an idea that came to me in the shower about 3 years ago. I was thinking about what serverless hosting lets you do. The fact that you can use the Vercel, which was called Zeitnow at the time, just lets me deploy an application instantly by running a command. I'm thinking, okay, what can I build with this that's interesting if they won't let me use a relational database? And that's when I realized that back when I was working at the Guardian newspaper, like 10 years ago now, I had exactly this problem. The Guardian had all of this data that we wanted to publish, and we just didn't have an effective, productive way of taking a bunch of interesting data and sticking it online. The way we did it at the Guardian is we had Google Sheets. We'd stick it up as a Google spreadsheet and link to it from the Guardian's data blog. And that worked, but Google Sheets aren't the most sort of hackable and like a flexible thing for data, especially if your data doesn't fit in a single table. So the realization I had is that this problem that you have in journalism and in other fields where you want to share data that doesn't change very often, if you can get that data into a SQLite binary and then ship it with a web application, especially since SQLite is part of the Python standard library, you don't even need any additional dependencies for that to work. That suddenly gives you the flexibility to all sorts of stuff. So the original idea was statically publishing data, immutable data online as quickly and easily as possible. And the more time I spent with this, the more I realized that SQLite is capable for so much more than just statically publishing chunks of data. And so over the past year, a big focus around dataset has been changing it to be able to support plugins that can ingest data, that have databases that actually update on disk and so on. How do you feel about the privacy ramifications of all these devices storing data like locations? I've got a demo for that. So I've got all of my locations from Apple, and I like Apple because they keep the stuff on my device and they don't load it to the internet. Google, on the other hand, have a crazy amount of data, which they do upload to the internet. So this right here is a table I built by hitting the Google Takeout tool, where Google Takeout lets you export all of your Google data. And so I've got a little bit of code I've written that can take some of that in. But this is everywhere that Google knows that I have been in I haven't updated this in a while, but this is like several years worth of Google's model of my location. And it's insane how much they know about where I've been going. Like when I zoom in on the, oh, it's loading in 21,000 points. But yeah, you zoom in on here and you can see me crossing the Golden Gate Bridge. Oh, what happened there? That's Mexico. That's not where I want it to be. Yeah, here we go. Here's San Francisco, and there's like a trail of me heading over the Golden Gate Bridge at some point. So this really opens your eyes to how much data there is about you out there. And you can see the sort of like WhatsApp leaked my location to Google at some point. I have no idea why. I wonder I hope this is the Google one. This might be one that might be a table I pulled in from somewhere else. But anyway, something that's happened that's really, really exciting is in Europe, they passed the GDPR privacy law, which means that every company in Europe has to give you a way of getting your data back out. And American companies are like, well, there's no point in us building this and just restricting Europeans. So any of these services that you use, buried somewhere in the preferences, there's an export button. And when you click it, they will probably email you like a gigabyte of XML or JSON or whatever it is. The thing that I'm trying to do with the Dogsheep projects is build those tools to take whatever that dump is and turn it into something actionable that you can work with. And that if all of this data is out there, at the very least, we should be able to see what it is and start using that for our own benefit, I think. Did you get exposure at The Guardian to any numbers that showed how presentation of data journalism projects increased engagement with content? It was 10 years ago, so off the top of my head, I couldn't answer that question at all. What I would suggest is, if you're not on there already, there is a Slack called News Nerdery, which is a Slack for newspaper. It's for nerds who work at newspapers doing data stuff. And it's got like 4,500 people in it from lots and lots of different publications. There would be people in there who would have a much better answer for that kind of question. I feel like I'm seeing some really exciting stories coming out of newspapers these days around this kind of stuff. One of my favorite examples, the LA Times have a data desk, which they've been investing really heavily in. And all of their stuff is on GitHub. So if you go to github.com/datadesk, this is actually, I'm pulling in their coronavirus data. They're doing wildfire stuff, the LAtimes.com. The California fire map they're running is a phenomenal piece of data journalism, which they haven't been sharing the numbers, but I believe they're getting some pretty good engagement from this. So yeah, so I don't have good numbers for this, but it's a world that I care very deeply about. Can you deploy a data set with some sort of authentication to prevent others from accessing your data? You absolutely can. The Dogsheep demo that I just showed you, if I go there in an incognito window, it's going to tell me to, it's better. It'd be embarrassing if this doesn't work. Here we go. So this is protected by a plugin I wrote that requires GitHub authentication. And you've got to sign in as Simon W. As my personal GitHub account to get access to that. I've also got a bunch of authentication plugins. So dataset auth. So dataset auth passwords is unsurprisingly a very simple password-based authentication. And so this one here, if I'm logged out, I only get access to the public database. If I click log in and log in with root and password with an exclamation, that gives me access to a private database as well. So yeah, there's a whole bunch of authentication stuff. And actually, this is all pretty new. A couple of months ago, I released a new version of Dataset with a whole bunch of plugin hooks for adding authentication permissions. Okay, and I think that's all of the questions. So, if there are any more questions, feel free to add them to the document. But yeah, I think that's everything I've got for you today.
Myself to this tree.
I'm just quickly scrolling through the chat as well. Okay.
Well, thank you very much, Simon. That was very enlightening and seems very powerful. And I might have to actually start looking into using this. I appreciate you lending your time to us, and I hope you'll join us in Discord after this.
Absolutely.
There's one taker for the PyCharm license, so David Moore will get you in touch with Chris to get the license over to you. But with all that, thank you everyone for joining us, and we'll see you next month. Bye.
Cool. Thanks a lot.